Okay, in conditional probability, we are going to actually try to analyze this question. If two cards are randomly drawn without replacement, it means that when a card is taken out, it's not replaced. From a standard deck, find the probability that the second card is not a heart, given that the first card is a heart. So what do we have here? We have a standard deck. In a standard deck, we have what we have here, like 4 types of cards. We have the white, with the red cards, and then we have the black cards. I used the white here. So for the red cards, we have the hearts, we have the diamonds. We have the 3 leaves for the black, and we have the spades. The 3 leaves, these are called the shrubs. From each and every type, we start from A, then 2, 3, 4, 5, 6, 7, 8, 9, 10, J, K, Q. For all of these cards, if you add all these cards, there are 52. Why is it called sample space? Because these are all the possible values that I can have from a deck of cards. But when we are going to calculate our probability here, find the probability that the second card is not a heart, given that the first card is a heart. So we are given the new sample space. So this part is going to give us the reduced, let me write it, reduced sample space. Meaning, from this sample space, I don't need everything because I have a condition. So the condition always gives you, or it reduces the sample space to the sample space that you need to use in your calculation. The first card that I picked was a heart, right? So we don't know which card was it, but it was a heart. So let's just see, scratch one heart. We just chose 2. It doesn't mean that it will be 2. Maybe it was a 3, but we are just scratching 1. So how many cards are left now? It means that I'm left with 51 cards. Why? Because when I took out one heart card, I did not return it because it was without replacement. So I took these 2 out and just stopped like that. Nothing else happened. Then, now I am told from here, what is the probability of picking a card that is not a heart? Which cards are not a heart from here? All these other cards are not a heart. So the probability of picking, how do we write it now? The probability of that the second card is not heart, given that, so this line means given that the first card is heart. First is heart. Okay, I'm just trying to shorten it. First is heart. What is that probability? That probability is, we're going to take these, and those. Those are the not hearts card. So we have 13 times 3, which is 39. So there are 39 cards over how many? What was the total? It was 51. Remember, we are using the reduced sample space because the condition has reduced the sample space for us. Always remember, the condition reduces the sample space. Yes, we may have a lot of possibilities, but the condition reduces the sample space for us. Okay, let's try having another question. 2 dice are rolled. Find the probability that 2 ones occur, given that at least 1 dice shows a 1. I just wrote 2 questions here so that we can understand. But when we roll 2 dice, what is the sample space? That's the first thing we need. Like when we had our situation here, we talked about the sample space first. So we also need a sample space here. So let's say we roll our dice let me write the sample space here. Sample space. Sample space are all possible values that I may have here. So I may have here the first die. Let me write the first one. The first die has possibilities 1, 2, 3, 4, 5, and 6. And then the second die, let me write it here. Second die is going to also have 1, 2, 3, 4, 5, 6. So it's possible that we are going to start with the first to the second. We may have a 1 and a 1, right? This. Or we can have a 2 and a 1. 2 and 1. We can have a 3 and a 1. And then 6, 6. Now the question is saying that 2 1s, okay, given that this is the new sample space, right? This is the new sample space for this sub-question, the reduced sample space. So the reduced sample space is going to deal with what? It shows at least 1, right? At least 1 dice shows 1. So in this, we want only the parts that will show a 1. Which parts show a 1? This part shows a 1. 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 But all these, there is no 1 here. So our reduced sample space is this one. That's our reduced sample space, right? This is our reduced sample space. Now, what is the probability that the ones, probability that they are 2 1s, given that at least one shows, or at least 1 dice shows a 1. So let me just write it this way to avoid trying to cut our video short. So from here will come the probability that we want is a 2 1s here. Where do we see 2 1s in our new sample space or the reduced one? Here there are 2 1s here. So how many are they? There is only here. So it's 1 over how many outcomes do we have in our reduced sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have a new total outcome of 11. So this is our answer. Whether you're going to write it as a percentage or what, but this is what we do. Then lastly, the sum of 2 dice outcome is 6, given that the sum is less than 9. So let's do this. Let's reduce our sample space as well. Probability. Okay, before we talk about probability, let's reduce our sample space. Given that we are told here, given that the sum is less than 9. So if the sum is less than 9, let's look for that are more than 9. Let's just scratch it off. Okay, 6 plus 1 is 7. 6 plus 2 is 8. 6 plus 3 is 9. But if we have 6 plus 4, it will be a 10. So it's more than 9. So 6 plus 4 here, we don't want that. We now scratch this. It's more than 10. If we come 5 plus 5 is 10. We don't want that. 5 plus 4 is 9. And all other below, they are going to be less than 9. Oh, they said less than 9. So even 9, we don't want it. So even this one, we don't need it. We don't need it. 5 plus 4 is 9. We don't need it. 3 plus 6 is 9. We don't need it. So all these, we don't need them because they are more than or they are equal to 9. We need less than 9. So our reduced sample space is going to deal with everything else that I didn't scratch. By the way, these things I circled them for first question. So now we are on B. Probability of the sum of the dice is 6. Sum 6. Given that a sum is less than what? Is less than 9 is equals to, okay, now from here, I need to look, by the way, what my reduced sample space is what now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. It's 26 outcomes. So out of those 26 outcomes, we are saying we want those that has sum of 6, right? Let's try 5 plus 1, it's 6. Okay, 4 plus 2 is 6. 3 plus 3 is 6. Usually you just walk in diagonals for this. 2 plus 4 is 6. And then 1 plus 5 is 6. So how many are they? 1, 2, 3, 4, 5. So the answer is 5, 26. So that's the probability. So whatever we did here, we were using that information that we talked about at first. So I hope you understood clearly what it means to have a conditional probability, that the condition is just going to restrict your sample space. Hope you understand. Goodbye.